and it's also loose on the back. This looseness allows for a full range of dorsiflexion and plantarflexion.
Now we'll move on to look at the two joints of inversion and eversion. There's one directly beneath the main part of the talus called the subtalar joint, and there's one below and in front of the head of the talus that has an unwieldy name, the talocalcaneo-navicular joint. We'll call it the TCN joint for short. To understand these joints, we need to get acquainted with the remaining tarsal bones.
We already know the talus, the calcaneus, and the navicular. In front of the navicular are the three cuneiform bones, first, second, and third. Lastly, the bone in front of the calcaneus is the cuboid bone. Now let's look at the calcaneus by itself. The posterior part of the calcaneus forms the heel. The massive calcaneal tendon, also called the Achilles tendon, is attached here. Here on the medial side there's a projecting shelf which the medial part of the talus sits on, called the sustentaculum tali. On the front of the calcaneus there's an articular surface for the cuboid bone. On the upper aspect of the calcaneus there are two articular surfaces for the talus, a small one in front, a larger one behind. The larger of these two surfaces, together with the corresponding surface on the underside of the talus, forms the subtalar joint. The head of the talus fits into a socket, which we'll see by taking the talus away. The socket is formed by this surface of the calcaneus, this surface of the navicular bone, and by a strong ligament here, which we'll see in a minute. These surfaces, together with the head of the talus, form the talocalcaneo-navicular joint. Here's what these joint surfaces look like in the living body. The surface for the subtalar joint, and the two surfaces for the TCN joint. This structure in between, which forms part of the TCN joint, is the upper surface of the strong calcaneo-navicular ligament, also misleadingly called the spring ligament, which helps to hold up the head of the talus. It goes from here on the calcaneus to here on the navicular. The movement that happens at the subtalar and TCN joints is a rocking motion that takes place around an obliquely placed axis. This rod shows the position of the axis. It's oblique to the long axis of the foot, both in this plane and in this plane. Here's eversion, here's inversion, again eversion and inversion.
Several strong ligaments hold the malleoli, the talus, the calcaneus, and the navicular bone together. On the medial side, which we'll see first, there's one extensive ligament to look at, the deltoid ligament. We've seen part of it already.
Now here's the whole of the deltoid ligament. This is the part we saw before, going from the medial malleolus to the talus. In addition, parts of the deltoid ligament fan out below onto the sustentaculum tali of the calcaneus, and in front onto the navicular bone, so that the deltoid ligament holds all four of these bones together. On the lateral side there are two important ligaments. The calcaneo-fibular ligament, which goes from the lateral malleolus to the side of the calcaneus, and this strong ligament, the interosseous talocalcaneal ligament, which goes from here on the calcaneus to here on the talus. To see that ligament better, we'll remove the talus. The interosseous talocalcaneal ligament lies between the subtalar joint and the TCN joint.
Now that we've seen the ankle joint and the joints of inversion and eversion, we'll look very briefly at the remaining joints of the tarsus.
Between the navicular and its neighbors, the cuneiform bones and the cuboid bone, there's hardly any movement, but there is a small amount of rotation between the cuboid and the calcaneus, which lets the front part of the foot invert and evert a little independently of the calcaneus.
We'll see more of the bones and ligaments of the foot in the next section. For now, we've seen enough to understand how the joints of the ankle region move. Before we go on to look at the muscles that produce those movements, we need to take a look at some important pulley-like structures that are attached to the bones of the ankle region. These are called retinacula, the singular of which is retinaculum. Each retinaculum guides and keeps in place a set of tendons that pass from the leg to the foot. There's a retinaculum on the front of the ankle and one on each side of the ankle, behind and below each malleolus.
Here on the front are the upper part and the lower part of the extensor retinaculum. These aren't isolated structures, they're localized thickenings of this layer of investing deep fascia, which we'll meet later. 4 tendons, a nerve and an artery, pass under the extensor retinaculum. On the lateral aspect, behind